Hello students, this is chapter 2 polynomial and we will do exercise first C in which we will solve the question based on remainder theorem. So in this exercise here are 11 questions. These are all the questions up to 11. Now let's start the exercise. This is first question. This is the polynomial px and it is divided by x minus 1, and by remainder theorem, if px is polynomial of degree greater than and equal to 1 and when it is divided by the linear polynomial x minus a, then pa is remainder. So what are you watching here? This a will be in the form of remainder. So it means when you substitute x minus a is equal to 0, then x is equal to a, and put the value as a in place of variable x. So here this is the linear polynomial x minus a. So substitute x minus 1 is equal to 0. So first you write by remainder theorem, by the remainder theorem, because here the questions are we will solve using remainder theorem. By the remainder theorem, we know that when px means polynomial in x is divided by, this is our polynomial, is divided by x minus 1, the remainder is p1. Now put the value in the expression. So p1 is equal to, see this expression, 1 cube, x cube means 1 cube minus 6 into 1 square plus 9 into 1 plus 3. Now 1 minus, this is 1, so this is 6 plus 9 and plus 3. This becomes 9 plus 3, 12, and 1, 13, minus 6 is equal to 7. So P1 is equal to 7. Answer. P1 is equal to 7. So our remainder is 7. Now next part, second part. Second part is 2x cube minus 5x square plus 9x minus 8. This polynomial is divided by x minus 3, is divided by x minus 3. So using remainder theorem, put x minus 3 is equal to 0 and x is equal to 3. So we have to find out PA means, here this is the polynomial, so P3 is equal to 2 into, here 3 cube minus 5 into 3 square plus 9 into 3 minus 8. Solve it. 2 into 3, 3 is 9, 3 is 27 minus 5 into 3 3s are 9 plus 9 3s are 27 minus 8. So this become 54 minus 45 plus 27 minus 8. Add these positive numbers and you will get the answer 7 and 4 11 and 5 6 7 and 8. Now minus and minus, add these numbers, 8 or 5 13 and this is 5. Now subtract, you will get 28. So this is the remainder. P3 is 28. I think you know how to solve and get the remainder. This is the third part. Do yourself. I have done it and check. Now this is the part 4th. I have done it. You should try yourself and come to the next part, 5th. This is the polynomial and it is divided by x plus 2. I am solving here. See. Using remainder theorem. Using remainder theorem, we will put the linear polynomial equals to 0. So x plus 2 is equal to 0 and x is equal to minus 2. Here you will get p minus 2. Remainder is pa, so you will get, when you substitute this value in place of x, so this becomes minus 2 cube minus 6 into minus 2 square plus 13 into minus 2 plus 60. Now 2 to the 4 to the 8 minus 8 negative and it is odd power and this power become positive because even this minus sign will be positive, and 2 to the 4, 4 6 are 24. Now 13 to the 26 plus 60. Now solve it, you will get the answer. Add these minus negative numbers, so you will get minus 58 plus 60 is equal to 2. So remainder is 2. Answer. Now 6th part, do yourself. Come to the 7th part. This is the polynomial is divided by 2x minus 1. So using remainder theorem. Remainder theorem, we have to write this because in question we have to use the remainder theorem. And what is the remainder theorem? We have to substitute linear polynomial equals to 0. So you will get the remainder PA means the value of x is equal to 2x minus 1 is equal to 0 and you will get x is equal to 1 by 2 and this a, this is of the form of a, as we have to calculate PA. So here this is a polynomial in x and we have to find out PA means 1 by 2, P 1 by 2. On this value we will get the remainder from this polynomial. So P 1 by 2 is equal to 4 into 1 by 2 whole cube minus 12 into 1 by 2 square plus 11 into 1 by 2 minus 5. Now solve it. 4 into 1 upon 2 to the 4 to the 8 minus 12 into 2 to the 4, so 1 upon 4 plus 11 upon 2 minus 5. 4 1 the 4, 4 2 the 8 4 1 are 4, 4 3 are 12. This becomes 1 upon 2 minus 3 plus 11 upon 2 minus 5. Now here the denominator are same, 1 upon 2 and 11 upon 2, and this minus and minus, these will be at 5 and 3 will be 8. So you can write these two as 11 plus 1, 12 upon 2 minus 8, 2 1 are 2, 2 6 are 12. So this is 6 minus 8, you will get minus 2 as the remainder. This is the answer. This is the 8th question. This polynomial is divided by 3x plus 2 using remainder theorem. Put linear polynomial is equal to 0 and you will get x is equal to minus 2 upon 3. Now PA means P minus 2 upon 3 is equal to, put the values in place of x. So you will get the polynomial in minus 2 upon 3. Now solve it. 81 and this is even power, so this will be positive number. Now write it, 2 to the 4 to the 8 to the 16 upon 3 3s are 9, 3s are 27, 3s are 81 plus 54 into, this become minus, so right here minus 2 to the 4 to the 8 upon 3 3s are 9, 3s are 27. Now this will be positive even power, so minus 9 into 2 to the 4, 4 upon 3 3s are 9 minus, and this minus becomes plus, so this is 3 into 2 upon 3 plus 2. Cut this, 3 1s are 3, 3 1s are 3, 9 1s are 9, 9 1s are 9, 27 1s are, and 27 2s are 54, 81 1s are, 81 1s are. Now what you will get, this is 16 plus, no, this become minus, plus minus minus, minus 8 2s are 16, and this is minus 4, and here plus 2 plus 2. So this 16 will be cancelled, and 4 plus this is also cancelled. 2 plus 2, 4, and minus 4, you will get 0. So in this question the polynomials become 0. So this is the root of the polynomial and the remainder is 0. This is the 9th question. This is divided by x minus a using remainder theorem. Put this polynomial equal to 0, x is equal to a. So PA will be, substitute the value in place of x, you will get the expression like this. Now AQ cancel, and 2a minus a, you will get a. PA is equal to a. This is the remainder answer. See the question number 10. The polynomial ax cube plus 3x square minus 3 and 2x cube minus 5x plus a, when divided by x minus 4, leave the same remainder. Find the value of a. There are two polynomials and we have to find the value of a, and both the polynomials leave same remainder. Now let's start. Suppose this is px and other is p dash x, and both are divided by x minus 4. So both are divided by x minus 4. So using remainder theorem, we will put x minus 4 is equal to 0 or x is equal to 4. First we find the value P4 from this polynomial. P4 is equal to, from here, is equal to a x cube means 4 cube plus 3 into 4 square minus 3. Solve it, and what the value will get? 4 4 the 16 4 the 64 a plus 4 4 the 16 3 the 48 minus 3. Now 64 a and subtract 48 minus 3 45. This is from first polynomial. Now find out p dash and putting the 4 in place of x. This becomes 2 into 4 cube minus 5 into 4 plus a. Solve it. 4 4 the 16 to the 64 and 64 to the 128. Confirm it. 64 to the 2 4 the 8, 2 6 the 12. Correct. 128 minus 5 4 the 20 plus a. Now subtract 8 and this you will get 10 plus a. This is p4, this is p dash 4, and this is a remainder, this is also remainder, and both are equal. As according to the question it is given the remainder are same, so equate both the remainder equal. So write down remainders are same. Remainders are same in both cases. Equate 64a plus 45 is equal to 108 plus a. Now solve it. 64a minus a is equal to 108, and here 45 will be in this side minus 45. You will get 63a is equal to 3, 8 minus 5 3, 9 minus 4 5. So a will be, write down here, 8 minus 5 3, and here 10 minus 4 6. This is 6. Correct it. So you will get a is equal to 63 upon 63 upon 63. A is equal to 1. A is equal to 1. Answer, which we have to calculate. Find the value of a. A is equal to 1. See the question number 11 as we start the solution. The polynomial fx, this is, when divided by x minus 1 and x plus 1, leaves the remainder 5 and 19 respectively. Find the values of a and b. Hence find the remainder fx is divided by x minus 2. So what to do with this question? This is a polynomial and it is divided by the first is x minus 1 and second is x plus 1. So in both the cases remainders are given. So we will make the two equations and we will solve the equation, and then we will get the value of a and b and put the value of a and b in the polynomial. So you will get the polynomial in x, totally x and constants. Now after that the last part is find the remainder. So substitute x is equal to 2. So you will get the value f2, and this is the solution. See how to do. And this is the solution when this polynomial is divided by x minus 1. So when fx is divided by x minus 1, put x minus 1 is equal to 0, x is equal to 1. So find the value f1. f1 is equal to 1 to the power of 4 minus 2 into 1 cube plus 3 into 1 square minus a into 1 plus b. This thing is equal to 1 minus 2 ones are 2 plus 3 ones are 3 minus a plus b. So you will get 3 plus 1 4 minus 2 2 minus a plus b, and the remainder is given 5. f1, this is the remainder, and in first case the remainder is given 5. So equate 2 is equal to, write down here in starting you can write it is equal to 5 because it is the remainder at the value of 1. So this is equal to 5. Now minus a plus b is equal to, so you will get 5 minus 2 is equal to 3. This is the equation first. Similarly for second, when fx is divided by x plus 1 and leaves the remainder 19 in this case. So put the value x plus 1 is equal to 0, so that x is equal to minus 1. Now f at minus 1. When you substitute the value in place of x, then it is the remainder. When you calculate it, you will get the remainder. So write down minus, in this polynomial we are substituting minus 1 to the power of 4 minus 2 into minus 1 cube plus 3 into minus 1 square minus a into minus 1 plus b. Solve it. This is the even power, so this is 1, and odd power, so you will get minus 1 minus minus plus 2, and here even power, so you will get plus 3, and here minus minus plus a plus b, and equate it, remainder as 19. This is equal to 19. Solve it. 2 plus 1 3 plus 3 6 plus a plus b is equal to 19, or a plus b is equal to 19 minus 6 is equal to 13. This is the equation second. Now solve these two equations so that you will get the value of a and b. So equation first and second, solving equation first and second, minus a plus b is equal to 3 and a plus b is equal to 13. No need to change the sign because already these are plus minus. Subtract it. You will get 2b is equal to 16, or b is equal to 2 ones are 2, 2 8s are 16, 8. Substitute this value in any equation, in equation first. So you will get minus a plus b is equal to 3, minus a plus 8 is equal to 3, or a is equal to, this 3 come in this side and a become the other side. So a is equal to 5. Now you will get the values of a and b. Now substitute these value in the given polynomial. So you will get the polynomial in variable x and constants. Our polynomial is substituting the value of a and b in fx. So our polynomial becomes x to the power of 4 minus 2x cube plus 3x square minus ax means 5x plus b means plus 8. So our polynomial becomes fx is equal to, you will get like this. Now find the remainder when fx is divided by x minus 2. This is divided by x minus 2. So put x minus 2 is equal to 0. Now x minus 2 is equal to 0. To get the remainder, we have to substitute the value of x is equal to 2 in the polynomial. So find out the value. f2 is equal to 2 to the power of 4 minus 2 into 2 cube plus 3 into 2 square minus 5 into 2 plus 8. Solve it. 2 to the 4 to the 8 to the 16 minus 2 to the 4 to the 8 to 16, 8 to the 16. Now 2 to the 4 3 the 12 minus 5 to the 10 plus 8. This 16 will be cut, and here 12 and 8, 20 minus 10 is equal to 10. This will be 10. So f2 is equal to the value of polynomial f2 is equal to 10, which is the remainder. This is the remainder. Students, our first C exercise is completed now. If any problem, watch the video again, and please like, share and subscribe my video and give comments. Thank you.